All right, welcome to the Unit 3 review. In the following video, you're going to see some questions that are going to help you prepare for the unit exam next week. I will give a few pointers, a few hints, maybe an answer or two to these questions so that you can check your work. But for the most part, you should be able to complete these on your own. And of course we can discuss them tomorrow. You're also going to want to remember to write a question or answer a question on the comments, the page below. Make sure they're specific, and if you're answering a question or asking a question, make sure it's well written. Okay, so for each question that I put up, I'll give you about 7 seconds to pause the video and copy it down and try it, and then I might give you a hint or two, but I expect you to have a written out solution regardless of how much help I give you. So here's the first question. Not going to give you a whole lot of help here. I want you to try this one on your own. You might want to go back to your notes from today and yesterday to help you figure this one out, but for the most part you should be good to go here. All right, here we're going to use the binomial theorem to expand this binomial below. Chances are you probably want to review some binomial theorem. What the heck is it? Maybe you've forgotten. And so I want to give you some places that you can go to do that. So if you go to the end of Unit 2, starting with Unit 2.22, okay? So about 12 minutes in on Unit 2.22, at approximately 12 minutes in, is where I start discussing the binomial theorem. And then if you look at Unit 2.23, and I believe there's also a review question in Unit 2.24, those will also be helpful. All right. All right, here we want to simplify the following expressions to lowest terms and list any excluded values. So go ahead and pause the video, try this now. I want to give you a couple of words of advice. All right, I hope that went well. The first one is pretty straightforward, right? I want you to remember if you have a fraction like 3/15, the way that I simplify that is I factor them. So 1 times 3 over 3 times 5. And so I now see that 3 over 3, well, that's always going to simplify to 1 over 1. And so this fraction is the same as 1 over 5. Okay? Same idea here. We want to factor, and once we have the factors, we can start to think about canceling them. So go ahead and factor this numerator here. This one's fully factored, right? I already have my linear terms here. So see if you can cancel anything out, and then notice any excluded terms. So I'll just actually talk about this one here. So I can factor the denominator into x plus 3 and x minus 7. And so x plus 3 over x plus 3, well, that's the same as 1 over 1 almost everywhere. So when I simplify this, I end up with 1 over x minus 7. Now notice, what are the values that x can't be? Well, x certainly can't be 7, because that would make this 1 over 0. But x also can't be negative 3, because in my original expression, when x is negative 3, I'll end up with 0 over 0, which will be undefined. So there are two excluded values there. For b, want to do the same thing, same idea. Here you'll notice this can't be factored easily, so you can't just factor it. So what you'll want to do is you'll want to go ahead and use the quadratic formula to find the factors, find the roots, and then thereby you can find the linear factors. And you'll notice something interesting about those roots, right? Something interesting about this function. In other words, if you graph it, you'll note there's something interesting about the roots, and so that should lead you to some things, to some interesting understandings about the excluded values. Okay, I don't want to give too much away. All right, here the function f is defined below. Solve the equation f of x equals 5. So pause the video, give this a try. Hopefully that went well. Remember, when we set something equal to something else, we want to know where this intersects that. So I want to know where this expression, if I were to graph it, would intersect the expression 5. So the couple ways I can do this, right? First off, I can just set it equal to 5 and solve. I can also graph this. So we're not going to want to graph this by hand, but I encourage you to use Wolfram Alpha. So go on Wolfram Alpha and graph it out. You can sketch a graph for yourself, and then you can corroborate your solution. Okay? If I am correct, the solution that you should be looking for is x. Well, actually, I don't need to give you this. You can go ahead and use Wolfram Alpha to solve for yourself and make sure that you get the correct answer. And finally, I want you to solve the following equation for the variable n and explain if there are any extraneous solutions. So go ahead and pause the video and give this a try. I will give you one hint after you've tried it out yourself. So notice, and this is my hint here, that if you had the equation 4 over x plus 1 equals 7, that you would be able to solve this fairly easily. Your first move would be to get x out of the denominator. All right? So notice the setup here. You had a rational expression. You had only one rational expression on each side. That allowed you to solve it pretty easily. Now go back here and think about what you're going to need to do so that you have one rational expression on each side. Okay? And then go ahead and solve. All right. I hope this goes well. Make sure that you post a question or answer a question in the comment box, and we will talk tomorrow.